Hello everyone, today we're going to be going over the January 2025 Algebra 2 Regents exam. In this video we're going to be focusing on part 2, which are 8 short response questions, each worth 2 points. A link to this test can be found in the description of this video if you want to follow along at home, alongside videos that go over part 1, 3, and 4 of this exam, so please check those out. That being said, we're going to start off with number 25, which asks us to describe the translations that map f of x is equal to log x onto g of x, which is equal to the log of x plus 3 minus 5. So whenever you're translating something, you can translate something in two directions, either up and down or left and right, okay? And there's certain indicators to tell you whether you're going up or down or left and right. The biggest indicator is if you have the function f of x and you're adding 5 or you're subtracting 5 from the outside of it. If you're adding something that you're translating up, and if you're subtracting something, that means that you're translating it down. So for example here, we see how we have minus 5 attached to f of x, right? We originally had the log of x, which looks something like this, but now we subtracted 5 from it, right? We didn't subtract 5 from x, right? We didn't do the log of x minus 5, right? That would be something different. What we did was we did the log of x, and then outside of the log, right? Just after the function was stated, we say, oh yeah, by the way, shift it 5 units down, make it 5 units lower. So now the function is going to probably look something like this. It's going to be 5 units down. So remember that whenever something happens outside of the parentheses, right, it's going to be a shift up and down. Then, that's not all what we have here, right? We also have the log of x plus 3, right, in addition to that minus 5. So whenever you have something that's happening to the x, for example, x plus 3, or f of x minus 3, that's going to be a shift to the left or a shift to the right. So notice here how this 5 was not attached to this x, but this plus 3 is attached to the x. So because the plus 3 is literally happening to the x, that means that we're shifting to the left or the right. So in this case, because we're adding 3, that means we have to shift 3 units to the left, which is this direction, right? So not only is it 5 units down, but it's also 3 units to the left, which looks something like this. Okay? So just remember these rules, you'll never get a problem like this wrong. So we can say that it is translated 5 units to the, not translated 5 units to the down, translated 5 units down, and 3 units to the left. And that's all we need to do to get full credit for this question, okay? 5 units down, 3 units to the left. If you did not remember these rules and you don't plan on remembering these rules, what you can do is you can graph these functions. If you go to y equals and graph log of x, and then here log x plus 3 minus 5. Hit graph, you can see here how this one is for sure going to the left and going down. Remember the red function is the second one. So if you wanted to map this blue function onto this red function so that they take up the same space, well, what do you have to do? Just move it down 5 units into the left 3 units, right? And you can verify that with all the points. Like all the points here are going to be 3 units to the left and then 5 units down, okay? So number 26 asks us to solve algebraically for x here. We have 1 over 2x minus 5 over 6 is equal to 3 over x. So in this case, what I have to do is I have to combine like terms. So what are my like terms? Well, I know that any term with an x is going to be like, and any term with a number is going to be a like term. In this case, I only have one term that's just made fully of numbers, 5 over 6, but I have two terms that have x in it. So I know that these two terms right here, this 1 over 2x and this 3 over x, are going to be like terms, so I can combine them. And in this case, I'm just going to subtract both sides by 1 over 2x, because I want my x to be on my right side, right? So now what I'm left with is I'm left with negative 5 over 6 is equal to 3 over x minus 1 over 2x, okay? And here's the thing, right? Whenever you're subtracting fractions, you need to make sure that they have the same denominator, okay? Or the lowest common denominator. So in this case, this denominator is 2x and this denominator is x. So what's the smallest version of this that I can turn both of them into? And that's going to be 2x, right? If I have x, if I multiply x by 2, I turn it into 2x, which is the same denominator here. So that's going to be the lowest common denominator, okay? Don't let this part confuse you. Oftentimes, you're just going to match one denominator to the other. So, if you had 5x, 1 over 5x minus 3 over x, usually you just have to pair this denominator with the other denominator. How do you do that? We'll just multiply by 5, okay? Usually, the Regents makes it that simple, right? You just have to turn one into the other by multiplying the top and the bottom by a number. So if I want to turn x into 2x, I just have to multiply the top and the bottom by 2 over 2. So I'm left with negative 5 over 6 is equal to 6 over 2x minus 1 over 2x. And this is going to turn into negative 5 over 6 is equal to 5 over 2x. And whenever I have a fraction like this, or whenever I have two fractions that are set equal to each other, what I can do is I can just cross multiply, right? So I multiply the top right here by the bottom right here. Make sure to include the negative sign, right? If you have negative 5 over 6, that's the same thing as saying negative 5 divided by 6, or negative 5 on top, positive 6 on the bottom. So when I go and cross multiply, I'm cross multiplying this negative 5 by this 2x. Negative 5 times 2x is negative 10x, and that's going to equal to 6 times 5, which is positive 30. So negative 10x is equal to 30. I can divide both sides by negative 10, and I get that x is equal to negative 3, which is going to be the correct answer. So the trickiest part for this problem was just knowing how to literally subtract fractions and remembering that you must have a lowest common denominator, okay? Number 27 says that given the cosine of theta is equal to negative 2 over 7 with theta being in quadrant 2, find the exact value of sine theta. So to do a problem like this, all you have to do is just draw a right triangle, okay, and assign sides. So notice here, or always remember the saying SOHCAHTOA. What this says is that the sine of theta, or the sine of any angle, theta is just how we say, it's like x but for an angle, right? It's a variable for an angle. An unknown angle, if you want to put it that way. So the sine of theta is equal to the opposite side over the hypotenuse, the cosine of theta is equal to the adjacent side of the hypotenuse, and then the tangent of theta is equal to the opposite side over the adjacent side. Now, how do you know which side is opposite, adjacent, to the hypotenuse? Well, one of them is super easy to figure out. In a right triangle, you're going to have this like L shape, right? Something like this. And at this L, you're going to have a right angle, which is 90 degrees in measure. So the side that's opposite this 90 degrees is going to be the hypotenuse. So if I drew a line straight from this 90 degrees going outwards, like so, whichever line it touches first is my hypotenuse, okay? The next two sides depend on the angle. So let's just say that my angle theta is, this dark blue angle over here, right? Let's say that this is theta. Whatever's opposite this angle is going to be my opposite side, right? Things in math usually are named to make sense, right? So if I draw a straight line outwards, it's going to touch this side, so this side is my opposite side. I'm just going to call that O. And finally, whatever side is remaining after you say your opposite and your hypotenuse is going to be your adjacent side, which I'm going to put in green down here. Okay? Also, the adjacent side is just the side that touches the angle, theta, that isn't the hypotenuse, right? So you see how two sides touch theta technically? It's the one that isn't the hypotenuse that's still touching the angle, right? So in other ways, it says that cosine of theta is equal to 2 over 7, right? Or negative 2 over 7, doesn't really matter. So a cosine of theta is equal to the adjacent side over the hypotenuse. So if this is my theta and I found its cosine, that means that its adjacent side has to be 2. Okay, so, well, we just labeled the adjacent side down here, so we can say that this is 2. And now it's over 7, right? Cosine is adjacent over hypotenuse, so I know that my hypotenuse is also 7, okay? So now I hope you guys see where I'm going with this, right? Because if I want to find the sine of theta, well, sine is equal to the opposite over the hypotenuse, right? Which in this case we need to solve for. And if you remember anything from geometry, or if you took the SHSAT, you know that for a right triangle, a squared plus b squared is equal to c squared. So if you have a right triangle that looks like this is a, b, and c. If you square these two sides and add them together, it's going to equal to the hypotenuse squared. So in other words, my opposite side squared, I'm just going to call that x. So x squared, this side squared plus this side squared, which is 2 squared, has to equal to 7 squared. Or x squared plus 4 has to equal to 49. Or x squared is equal to 45, and x has to equal to the square root of 45. Okay, so this opposite side we now just found to be the square root of 45. And now, if I want to find the sine of theta, well, the sine of theta is equal to the opposite side, which is radical 45, divided by the hypotenuse, which is 7. So sine theta has to equal to radical 45 over 7, and that's going to be the correct answer here, okay? So I understand that this explanation might have sounded a bit long, but all I did here was I just explained what the opposite adjacent sides were, I explained what trig functions were, and I explained to you how you can use trig functions to draw this hypothetical triangle to get the value of another trig function, okay? Always draw a triangle, always remember SOHCAHTOA, write it out like this, you won't get a problem like this wrong. All right, number 28 says, use the properties of rational exponents to determine the value of x for the equation below. So the way that I like to operate around these problems is I treat the numerator and the denominator different, and then I, try and evaluate them, okay? So what I mean by that is I'm not going to look at 5 root a to the power of 10 and a cubed over 1/2 at the same time. I'm going to go ahead and I'm going to simplify both the numerator and the denominator separately, and then I'm going to recombine them in a new fraction that I can actually work with. So I'm going to start looking at the numerator. Inside the numerator, I have this. I have 5 root a to the power of 10. And you should always know this. If you have a to the power of, b over c, right? This is equal to the c root of a to the power of b, okay? In other words, if you have a to the power of b over c, whatever's in the denominator goes on the outside of the radical, and whatever's in the numerator goes as the exponent to that base. So it goes right here. So whatever's in the denominator goes here as your c, and whatever's in the numerator goes here as your b. So if I have 5 root a to the power of 10, well, whatever goes here has to be your denominator, right? So if I have 5 root 10, right, this maps onto the denominator. So it's actually equal to a to the power of, 10 divided by 5. Okay, so always rewrite it like this. Whatever's on the outside goes in the denominator. Whatever's as the exponent goes in the numerator. So this is actually equal to a to the power of 10 over 5. And we know that 10 over 5, well, that's just 10 divided by 5, which is equal to 2. So a, or this value, right, 5 root a to the power of 10 is actually equal to a squared. And that's a form that I can actually work with to simplify the rest of this fraction. So I'm going to write it down as a squared divided by whatever my denominator is going to turn into. So my denominator is even easier to work with, right? If you have a to the power of b, and then in parentheses, it's raised to another power like c, this is equal to a to the power of b times c. So in this case, we have a to the power of 3, and then in parentheses, it's being squared to, or not squared, but raised to the power of 1/2. Instead of having this ugly parentheses and 2 exponents, I can combine them into 1 exponent by just multiplying them together. So this is actually equal to a to the power of 3 times 1/2, which is equal to a to the power of 3 over 2. Okay? So now I have a squared over a to the power of 3 over 2. Now, you may be asking me, well, how did this help me? This helped me because now that they're both in the same form, they're both in terms of numbers, right? This one was in terms of, a radical symbol and something being raised to the power of 10. And this one was in terms of a fraction and a whole number. They're both in terms of regular numbers. And this is important because whenever you divide two exponents, whenever you have a to the power of b divided by a to the power of c, that's equal to a to the power of b minus c. Okay? So what I can do here is I can just say that this is equal to a squared, right? Because the top number goes first, raised to the power of 2, because remember, write down the first exponent first, minus, because you're subtracting when you divide, minus 3 over 2, because the second exponent goes second, right? B goes first, C goes second. And now this is equal to a to the power of 2 minus 3 over 2, okay? So 2 minus 3 over 2 is equal to 1/2. So we can say that a to the power of 1/2 is equivalent to this stack right here. And remember, it said that this is equal to a to the power of x. We just found it to be equal to a to the power of 1/2. So x has to equal to 1 over 2, or 1/2, right? So again, the math here isn't difficult. The only math you had to do was you had to divide once, and then you had to multiply, and you had to subtract. And there were no variables involved. The difficult part here, and I think this is the difficulty of the Algebra 2 Regents, is just the number of stuff that you have to memorize, okay? So I'm just going to circle what you have to memorize. You have to memorize this. Dividing fractions equals subtracting exponents, okay? You have to memorize this. Raising a power to a power means multiplying the powers, okay? And then you finally had to memorize this, okay? Or I guess this, right? Ignore this box. Whenever you could always rewrite a radical as, a fraction, or exponents as a fraction, and then you can write them as a radical, or in radical form, okay? If you knew these 3 forms, you were good for this problem, right? And you got it correct. Number 29 asks us to graph at least one cycle of y is equal to 5 sine 4x minus 3 on the set of axes below. So let's go ahead and let's figure out what each one of these numbers means. This number right here is my amplitude. Whatever is before your sine or your cosine is going to be your amplitude. So if I had like 3 cosine 5x, this 3 would be my amplitude because it's in front of my trig function. Okay, so that's my amplitude. This 4x, well, my x is just my x, right? Nothing special about that. But this 4 is going to represent my frequency. And this -3 is going to represent my midplane. Okay, so let me just tell you how a wave looks like, right? So if this is your x and this is your y, a sine wave is always going to pass through the x, right? And it's going to look something like this. Up, down, up, down, up, down. Okay? I don't know if I drew it properly, but you should be able to see how this graph is always going a certain amount above the x-axis and a certain amount below the x-axis, right? And actually, those two values are equal to one another, right? And that's what we call our amplitude. So if this was our function here, we know that our amplitude would be 5. So you're actually going 5 above and 5 below. Okay, so plus 5 minus 5. You're never going higher than 5. You're never going lower than 5, okay? And essentially, you have parts in your graph where you're at your highest height and your lowest height. When you're at the highest, that's a peak. When you're at the lowest, that's a trough, right? Or a dip, okay? And essentially, one complete cycle is when you go from the start all the way to the end, right? So one cycle has to complete or has to show one complete peak and one complete trough, right? So one peak and one dip. So a cycle always looks something like this, right? You have to go up and you go back down, okay? Or a cycle can look something like this, right? So this is one cycle for a sine function. This is one cycle for a cosine function, right? Because cosine starts at a peak, then it dips, then it goes back up to a peak. So because this is a sine function, we know that we need to graph one of these instead of one of these, okay? And again, we see here how since this is a sine function, you start here, you visit your peak, you visit your trough, and then you go back to where you started. And that's going to be one complete cycle, okay? The last thing I want to talk about here is going to be the midplane, okay? The midplane, in this case, is where the amplitude is going to be centered around. So we saw here how we're going 5 above and 5 below the x-axis. That means that the x-axis is my midplane. But in this case, my midplane is -3. So what's actually going to happen is this function is going to go up and down by 5, not around the x-axis, but around the line 3. So right here, let's just say that this is -3. That means that our function is going to go 5 units above 3, -3, and 5 units below -3. 5 units above, 5 units below, 5 units above, 5 units below. Like so and like so, okay? So this tells you the imaginary line that you're going to add and subtract 5 from, okay? And this tells you the frequency. So last thing I want to talk about is frequency, right? Frequency is how many cycles per a certain distance, right? When you graph one cycle, the period is the distance that you have to cover to run one cycle of your wave, okay? So for example, if this was graphed if this was the x-axis and this was 0 and this was like 2 pi, your period here would be 2 pi because that's the distance that your graph or your wave has to cover to complete one full cycle, okay? And we also know that whenever you have a period, the period is equal to 2 pi over the frequency. Okay, so in this case, my frequency is 4, right? It's not 4x, it's 4. That means that my period has to equal to 2 pi over 4, or pi over 2, if you simplify it like that. That means that whenever you cover a distance of pi over 2 on this graph, you would have had completed one complete cycle like so, okay? So that's all. That's just a basic review of waves. That's all you needed to know in order to solve this problem. Now we can actually solve it, right? So a wave is going to exist over 5 points. The Regents wants you to graph 5 points for a wave. The first point is going to be your starting position. The second point is for a sine wave. The second point is going to be the peak. The third point is going to be back to the midline. The fourth point is going to be your dip. And then the fifth point is going to complete the cycle. And then you're going to have a wave that looks something like this. So all in all, you had 1, 2, 3, 4, and 5 points, right? You know that your first point is going to start at the origin, 0, 0, and your fifth point is going to stop at your period, which in this case was pi over 2, okay? So the hardest part of this problem is to figure out the scale here. And all you have to really do is take your period and divide it by 4 to figure out the scale. Because if you don't put the right scale, if you don't put the right tick marks, oh, this is, pi over 8, this is pi over 4, so on and so forth, you won't get full credit. So you have to label which point is which. So if you take your period and you divide it by 4, that's 2 pi, so it's pi over 2 divided by 4, which is pi over 8, okay? So pi over 8 is what you're going to increase by for these 5 points. So you know that your first point is at 0, 0. That means that your second point has to be pi over 8 away from 0, 0, which is just pi over 8. Then you know that your third point has to be, again, the same unit away from here, from here. So if this was pi over 8 from here, and from here has to be another pi over 8. Pi over 8 plus pi over 8 is equal to pi over 4. Then finally, your fourth point has to be, again, add pi over 8 to this, and you get 3 pi over 8. And your final point is always going to be your period, right? So this point right here has to be your period, which was pi over 2, okay? So this is where your 5 points are going to occur, over this interval right here, from 0 to pi over 2, from 0 to your period. All I did right here was I figured out the scale here. You have to go up by pi over 8 each tick, or every 2 ticks, okay? Then finally, all you have to do is just follow my rule, right? If it's a sine function, start at the midplane. Our midplane here is -3, so draw a dashed line at -3. This is 1, 2, 3, so my midplane is going to be around here. So because this is a sine function, instead of starting at 0, 0, it's going to start at the midplane right here. Boom, like so. Then because it's a sine function, and it's a positive sine function, it's going to go up first. So you have to graph your peak first. You know that the first point you're allowed to graph on is pi over 8, and your peak is going to be your amplitude plus your midplane. So you're going to go 5 units above your midplane. Your midplane is -3. 5 plus -3 is 2. So at this point, your height is going to be 2. Then, for a sine function, your third point is going to go back down to the midplane, which is right here. Pretty easy. And finally, your what is this? 1, 2, 3. Your fourth point is going to be 5 units below your midplane. This is going to be your dip. So if your midplane was -3, then 5 minus -3 is -8, so you have to go -8 down. So 1, 2, 3, 4, 5, 6, 7, 8. That's this point right here. Okay? And then finally, to complete the cycle, you have to go back up to your midplane, which is going to be at the end of your interval, right, or at your period, which we determined to be pi over 2. Then, to get full credit, you just connect your lines with a curved line, like so. And then that's how you get full credit on this question, okay? So I tried to explain this the best I could. Again, in a summary, the amplitude is how many units above or below your midplane you're going to go. The midplane is just the center of the line, okay? The sine tells you what type of function you're going to go. For a sine function, you're going to go up first, then down, up first, then back to the midplane, then down, then back up to the midplane. So something like this, okay? That's going to be one complete cycle. This 4 is your frequency. If you take 2 pi over your frequency, you get your period, and your period is the distance that one cycle is going to occur over. So if you plot pi over 2, from 0 to pi over 2, that's the distance it takes for it to go up, back down, minimum, and then back up, okay? That's all you have to know here. Number 30 says, whose function is correctly written to reveal the approximate monthly depreciation rate? Okay, so we know that the annual depreciation rate, annual means per year, for the vehicle is 15%. So every single year the car depreciates by 15%, and this is the function in terms of the years per purchase, okay? So in this case, we want to find the depreciation rate per month, okay? And all you have to do here is you have to take the rate that they gave you here. So the depreciation rate inside of this function is 15, but when you do 1 minus your rate, you get 0.85. So all you have to do here is you have to raise the number inside of this parentheses to the unit of time that you want. So you can do 0.85 raised to the power of 1 over 12. Because if you think about it, right, if x is the number of years, x years is equal to, 12 months, right? There's 12 years in a month, and instead of saying x, let's just put 1. So you know that 1 year is equal to 12 months. That means that if you want to solve for 1 month, you just have to divide everything by 12. So 1 over 12 has to equal to 1 month. So if 0.85 is my yearly depreciation rate, and I know that 1 over 12 years is equal to 1 month, if I raise this to 1 over 12, I'm turning this yearly depreciation rate into a monthly depreciation rate. Okay, so in my calculator, I can go ahead and I could do 0.85 to the power of 1 over 12, and I'm going to get this number, 0.98654, right? And if we look at that, we'll just write it down, 0.85 raised to the power of 1 over 12. So this one, again, just for those of you that are still confused, this 1 over 12 is how many months are in 1 year. Okay, so if we raise this annual depreciation rate to this power, we're then converting this yearly rate into a monthly rate, because 1/12 of this is what you depreciate by every single month, right? So this is, in other words, this is the amount that you depreciate by in 12 months, right? Because that's how many years are in, that's how many months are in a year. 1 over 12 is how much you depreciate per 1 month, which is a monthly rate, okay? So we'll just write that this is equal to 0.9645 or 0.9865, okay? And if we look at whichever function has this rate, it's going to be Julia's function, okay? So we'll just say that Julia's function, or that Julia is correct, since 0.85 raised to the power of 1 over 12 is equal to 0.9865. And that's all we needed to do here to get full credit. All we need to show here is that we understood that her function had the correct rate. Okay? How do you find the rate? You raise it to the power of 1/12 for a month. Okay, number 31 asks us to write a recursive formula for this sequence. So when you're writing a recursive formula, you need to state 2 lines of math. The first line of math you need to state is the first term, which is a of 1. Okay, so a of 1 is equal to 8. If you're confused about this notation, a of n, a is the amount, okay? And n is the position. So a of n is the amount at a certain position. Okay, so every function starts at position 1, then it goes 2, 3, 4, 5, and 6, and so on, right? So this 8 is the first term, so its position is 1. So if you find the amount at position 1, it's just the value at position 1, which is 8, okay? And essentially a formula is going to tell you the amount at any position based on a rule. So your second line has to be equal to a of n. So the amount at a position is equal to something, right? So now we have to figure out that. So there's 2 types of sequences here. There's arithmetic and there's geometric. Arithmetic sequences are going to add and subtract. Geometric sequences are going to multiply or divide, okay? So in this case, for any type of sequence, you're always going to add or subtract by the same amount to get from one point to the other. For any geometric sequence, you're always going to multiply or divide to get from one term to the other. And it's always going to be by the same amount. So if we look here, let's just test if this is an arithmetic sequence. First of all, we're starting at 8 and we're going all the way up to 312.5. So we have to be increasing. And for you to increase, you can't be subtracting and you can't be dividing. So this function is either multiplying or adding a term to each next one, right? So if we start at 8 and I go up to 20, that's me adding 12. If I go from 20 to 50, that means I had to add 30. From 50 to 125, I had to add 75. So remember that any sort of sequence is always going to increase by the same amount each time. So are we increasing by the same amount here? No, we're increasing by 12, then by 30, then by 75. We're increasing by a different amount. So it can't be an arithmetic sequence, it has to be a geometric sequence, and we have to multiply the previous term by a number to get the next term in this sequence, okay? So how do we find that magic number? We'll just do 20 divided by 8, or the second term over the first term, okay? So 20 divided by 8 is equal to 2.5, okay? So essentially what we're saying here is that to get to the next term, you have to multiply the last one by 2.5. Does that make sense? Is 20 times 2.5 equal to 50? Yeah, you can verify it in your calculator. It is. So if you multiply that by 2.5, you'll get the next term. How do you go from 50 to 125? Oh, you just multiply by 2.5. How do you go from 125 to 312.5? Well, oh, you just multiply by 2.5, okay? So a of n, or the next term, is equal to 2.5 times the previous term, which we represent as a of n minus 1. Okay? So 2 lines of math. All you need to do here, box this, you get the right answer, okay? Just a quick note here, whenever they're asking for a recursive formula, your formula has to include a of n minus 1. Okay? That's all. If they wanted a geometric sequence, you wouldn't have to put a of n minus 1. You could just put a of n, right? But for a recursive formula, they're always looking for a of n minus 1, okay, in your formula, which just means the previous term. So to get to the next term, what we're saying here is just multiply 2.5 by the previous term, which is a of n minus 1, or the amount in a position that's 1 less than the current position, right? So if your current position is 5, a of n minus 1 is a of 5 minus 1, which is 4, which is the previous position, okay? Number 32 says a grocery store orders 50 bags of oranges from a company's distribution center. The bags have a mean weight of 3.85 pounds per bag, and the company claims that their bags of oranges have a mean weight of 4 pounds. Okay? So we have 2 different things, right? The grocery store says that they have a mean of 3.85, and the company that does the statistic test says that they have a mean weight of 4 pounds, okay? So the grocery store ran a simulation of 50 bags 2,500 times, assuming a mean of 4 pounds, and the results are shown below, okay? So the mean is 4, and the standard deviation is 0.026. Is the mean weight for the grocery store sample unusual? Explain the results of these simulations, okay? So again, like I said, they have oranges that come from a center, right? And essentially, the grocery store got a sample of oranges, and the mean weight, or the average weight for them, was 3.85 pounds per bag. But the distribution center, right, the people that actually distribute the oranges are like, wait, you got something that was 3.85 pounds? On average, we sell things that are 4 pounds. So the grocery store was like, well, I feel like we got ripped off a little bit. Let me quickly run a simulation to see whether or not this 3.85 is normal or not. And you may be asking me, well, how can you tell if something is normal or not? And that's whether or not it falls between 95% of the data, okay? So the 95% rule says that 95% of your data is going to be found between your mean and plus or minus 2 standard deviations, okay? So if something is further from your mean, for example, your mean right here is going to be 4, right? That means that 95% of the data can be found plus 2 times 0.26 in this direction and minus 2 times 0.26 in this direction, okay? So 0.026 times 2 is 0.052. So 4 plus 2 times the standard deviation is just 4 plus 2 times 0.026, right? And then you could also do 4 minus 2 times 0.026, okay? So 4 plus that is 4.025, right? So put that right here, 4.052, okay? And on this side, we'll do 4 minus that, and that'll give me 3.948. So what this rule states is when you find that plus or minus 2 times the standard deviation, 95% of all your data is going to fall within this range, okay? So that means that only 5% of simulations give you numbers that are outside of this range. Now, you tell me, if something has a 5% chance of occurring, is that normal? Is that common? Is that going to happen every single day? No. How about something that has a 95% chance of occurring? Is that going to occur pretty much all the time? Is that pretty common if something has a 95% chance of happening? Yeah, right? That's really close to 100%. So 95% of the bags are going to contain between 3.948 pounds and 4.052 pounds. Now, if we look back to our problem, it said that the grocery store had a sample that was 3.85. Is 3.85 between this? No, 3.85 is like way out here, right? So they've had a bag that falls outside of 95% of the data. That means that this bag that they found had a 5% chance of occurring, right? 5% of any sample will be 3.85 pounds. Is that normal if it was part of the 5%? No, it's not normal, right? So when they ask us, is the mean weight unusual? We say that yes, it is unusual, as the weight falls out of the 95% confidence interval of what we say it was 3.948 to 4.052. And that's all we have to state here. So if it falls within the confidence interval, it's not unusual. If it falls out of the confidence interval, it is unusual, right? And you just state what your confidence interval is, and so that they know that 3.85 is clearly outside of this, okay? And that's the end of this video. So if you have any questions, please feel free to let me know in the comments down below. I'll try my best to answer them. If you want to keep going over this test, guess what? Part 3 is already uploaded. Please check it out. Other than that, I hope you guys learned something, and I hope you have a nice day.